Thanks for coming. So like many of the speakers who have presented over the last couple of days, I'm coming to you from a foreign country, Iowa specifically. Believe it or not, we do have computers there, in addition to the other things you would expect, like corn, pigs, hillbillies. So we're talking about engineering for crisis response at scale. That is the title. The first part was just to get you in the door and firmly wedge a song between your ears. So crisis response at scale kind of being the operative thing here. Again, my name is Matthew Simons, and I work at Workiva. So I am going to talk a little bit about Workiva, not because I'm trying to sell you anything. In fact, chances are your company already uses our product. You just may not know it. We do compliance reporting software, really sexy stuff. And so your CFOs, your SEC reporting teams, those are the kind of people that use our software. And we've had to do some scaling over the years. So our story that very briefly I'll say we started in 2008, and we launched our first product in 2010. So we provide an SEC reporting solution. That was what we did in 2010. And by 2014, we had 70% of the Fortune 500 and 70% of the Fortune 100 using our product and doing their filings with our product. And in 2014, we went public. So we've had to do some scaling in a relatively short amount of time. And wanted to kind of talk to that today, and specifically how we've managed our crises and kind of the day-to-day operational firestorms that we all encounter. Before I switch to the next slide is Ben, the guy who did the presentation yesterday, the last session. Is he in here? No. Okay, if he was, I was going to ask somebody to hold him down before I go to this next slide. So this, yeah. So the reason he hates this, and the reason why I kind of love it, and I put it in here, it's sort of the impetus or the inspiration, I should say, for this talk. And the reason he hates it is because this is not what our job should be, right? This should not be our day-to-day, but we identify with it at a certain level. We identify with it because sometimes that's just what it feels like, right? Everything is on fire, and we're the ones who have to put it out. We're on the front lines with the fire extinguishers, and that's our job. That's what we do. It shouldn't be, but oftentimes it is. So the goal here is to give some pointers, talk about some things that have helped Workiva and the reliability team at Workiva get from this place to a better place. Get from this place to a place where things are a little less insane on a day-to-day. All right. I'm going to use some metaphors, some stories. There are three main principles I'd like to discuss today, and I'll go into some examples. And the metaphor that we'll kind of run with today is we're all on a ship. So for the duration of this talk, you and I, we're all in the same company, and we are on a ship. Now, this is a cruise ship specifically because cruise ships have customers, and we have customers. We have to look after our customers. Would have been fun to do like the Starship Enterprise, right? But our mission is different. We have customers. And it plays in for some of the reasons we use ships and other examples. You know, there's going down with the ship and all hands on deck and all those kinds of sayings that we tend to use in reference to a business context anyways. So we're all on a ship. Now, if I were to ask you and say, what are some of the threats to this ship, then the list we would come up with would probably look something like this. So we have external threats, right? We got our torpedo bomber there and our submarines lurking in the depths. People that are just out to get us. So this could be external security threats, things like that, competitors maybe. We have maybe internal threats. You know, we have maybe some access things we need to figure out. We have potential spies or turncoats. And we have environmental threats, so icebergs or Kraken, waiting to tear apart our ship. So I want to switch gears here for a moment. This is going to feel like it's coming way out of the blue. I promise I'm going to come back to this and relate it all. I want to talk about a different kind of crisis. Specifically, I want to talk about the crises, maybe the ultimate crisis for us as humans, which is the top 10 leading causes of death in the United States. So here they are. We have heart disease, cancer, chronic lower respiratory disease, accident, stroke, Alzheimer's, diabetes, flu, pneumonia, kidney disease, suicide. What's really interesting to me about this list is, first off, what's not on the list. What's not on the list is war. What's not on the list is hurricanes, earthquakes, natural disasters, tornadoes, and all kinds of violent crime, interpersonal, domestic, criminal violence, right? So all types of interpersonal violence. None of these things are on the list, and yet these are the things that scare us every day. The news reports violent crime. It doesn't report, Bob died of diabetes. Even though that happens way more often. These are the things that are actually killing us statistically more than anything else. And what's really amazing is when you break it down, almost all of these are preventable to some degree or another. Take heart disease. Heart disease, the leading risk factors being your diet and your exercise. And there are a number of other things, but those are kind of two things that actually run throughout this list. Cancer, the leading cancer being lung cancer, the leading risk factor being do you smoke? Chronic lower respiratory disease, there's a whole number of those, but if you look at that and look that up, again, the leading risk factor is do you smoke? Accidents, the number one accident being vehicles, so car accidents, and the biggest risk factors for that are reckless driving, drunk driving, and the other one flew away. But distracted driving is one of them, but it was drunk driving, not wearing seatbelts. Not wearing your seatbelt is actually, of course, a huge factor in terms of whether or not you die in a car accident. Stroke. Alzheimer's is kind of an interesting one. We're still kind of figuring out a lot of the causes of that, but we do know that one of the risk factors is how active is your mind? How are you keeping up your mind, exercising your mind? Diabetes, of course, the risk factors, again, come back to diet, exercise, smoking. These are recurring themes, and we could go through all of these. I've already done most of them, but the interesting thing here is that all of us had the secrets to life, longevity, and happiness and health since we were 10, right? Play outside, eat your vegetables, don't do drugs. These are very simple things, but they're maintenance items. They're maintenance items, and we're not real good at them, says the fat guy on stage. So is it any wonder, really, here comes the tie-in, is it any wonder, really, that the systems we build have some of these same weaknesses? Not exercise necessarily, but kind of maintenance items. The things that take down our systems really aren't very often these items, right? When it comes down to us, what sinks our ship more than anything else is plain old, boring as hell, everyday barnacles. These are maintenance items that go untouched. These are root causes that we just never quite figured out and kicked under the rug. And these come back to bite us. That's sort of where the metaphor breaks down a bit, because the barnacles on our hull don't just sit there. They do in normal everyday life, and that does a lot of things. It increases fuel consumption for ships. It drastically increases the cost of operating. But these barnacles, our barnacles, actually detach themselves from the hull every now and then, scramble up the side, rough up a customer, and then go back down. As I said, the metaphor isn't perfect. But that's what barnacles are. So going to the title then, Engineering for Crisis Response at Scale, kind of the smart-ass answer to how do you deal with crises at scale is actually to have fewer crises. It's true. That's just the deal with it. How do you scale with crises? Yeah, you can hire more people. You can have bigger teams. You can design huge processes and pipelines for dealing with these things. To some extent, we have to anyways, but really when it comes down to it, if you want to be able to scale, you have to reduce the number of barnacles on the ship. That's just what it comes down to. And it's not sexy. Nobody likes scraping barnacles, but it has to be done. And I want to talk about a few different ways for doing that. The first thing I want to talk about, this is more of a principle, but I will tell you kind of one way in which our company has done it. The principle is tighten your customer feedback loop. And in parentheses there, pain is good. The allocation of pain is something specifically that we're going to talk about. But tightening your customer feedback loop. Let's talk about Workiva for a moment again, going back to our scaling story. When we were a small company, when we were a number of devs just sitting around a table coding, I wasn't there at the time, I can't claim to have been part of that crew, but it's a phase that people are familiar with. You have a handful of customers, a handful of devs, maybe just one customer, right, an alpha customer, and your feedback loop is very tight. You're working with your customers. You make changes, they tell you they suck, you make different changes. That's how you build your product. This is kind of the lean startup methodology, right? You're just very agile, you're moving, you're moving, you're moving, you're moving. You get something that sticks and you maybe get more customers. Hopefully you get more customers. So what happens then, we figure out, at least for us, there's different ways in which this evolves, but we tend to add more layers. So for some, we say, you know what, engineers aren't that great at talking to people. Let's not have our engineers talk to people. And so they stick maybe a customer service layer in the way. For us, our customers are all white glove. And so we have our customer success people, right? We hire a whole group of people just to baby our customers, make them feel like the most important people in the world, who know everything about their business and are there to work specifically with them. So we add that layer. We get even more customers. And now what ends up happening for us is we add even another layer. So what we have is we have this primary contact with our customers who are giving us feedback, who are saying, we're having problems using your software. Here's something I ran into. They talk to our customer success people. Maybe for you, it's tech support people. It just depends. If you're selling to everybody and have 1,000 billion customers, then maybe that's your setup. For us, we have our customer success people, but our customer success people are trained in like accounting and in what our customers do. So when they get technical reports, we need to be able to vet those reports. We need to be able to really increase the quality of that information. The whole goal of this is to increase the quality of information going to our engineering team, reducing volume, distilling it down into what's really important so that we can make the right changes. We added even another layer on top of that where our first line of technical people, which is kind of the dude in the middle there, our first line of technical people then needed an escalation path. So we had even another link in the chain. But what you can see is that the quality of the information here changes. The quality changes as we add links in really the opposite way from what we intended. We put this in place to filter, to distill, to give us really the best information. But what happens is we get further and further away from it. And our engineers, the people making the changes who need this information, the people we're trying to feed the information to, end up getting worse and worse information. And the other thing that happens is the pain gets completely lost. And pain is important. Pain is good. If allow me a moment to bring another metaphor in. You have a child. Maybe you don't have a child. I don't have a child. But be a child for a moment here with me. You're whatever age you are when you first touch something hot. You touch the thing that's hot. You immediately feel that it's hot. Your hand hurts. You say, ow. You pull it away. Maybe you cry for a little while after. But that feedback was instantaneous. Instantaneous. The pain was instantaneous. The action is instantaneous. And we need that. We need that tight feedback loop to know what to do. As we add more links in the chain, it gets further and further away. Imagine now you're that same child, you put your hand on the hot item, hot plate, stove. You put your hand on the stove. Imagine if the pain doesn't come for 5 seconds. What happens then? Well, the damage is greater, the pain is greater afterwards, and the more latency we introduce into that system, the less likely we are to actually be able to positively associate the action with the pain. If that pain were a month away, a week away, hell, even an hour away, would we really know? As a kid, you put your hand on there, and an hour later it hurts. Where did that come from, right? Now, take this to a different example where we have a scenario, and this is not uncommon in our line of work, where you have developers who make a change, there's a regression, but the pain of that actually goes to an SRE team or an operations team. The people that actually deal with this, that revert the changes, that go in and rewrite or change the data that was munged because of this, they're the ones doing all the work, feeling all the pain. At the end of it, maybe they write a ticket, they throw it in, and it gets thrown in someone else's backlog. The problem there is that you're not even feeling the pain. If I put my hand on the stove and Bob hurts, how am I ever going to change my actions because of that? But we do this. As an industry, we do this. It's stupid, it's insane, but we do it. So we need to tighten the feedback loop. We need, as much as possible, to allocate the pain to the right place. Pain is a motivator. Pain is an agent for change, and we need it. I can't tell you how to do this in your organization. I can't tell you what's right for you. All I can tell you is that you need to evaluate your organization. You need to sit down and really take a look at the links in your chain. Who is between your developers and your customers? Are they all necessary? Do they all perform a function? Are there places where that pain maybe loses its potency along the way? And how can we change that? How can we restructure? How can we do things differently? At Workiva, we were able to take out that escalation path. It's the person I didn't put in, but we were able to take that out. That's how we were able to do it, and I'll tell you how we did that specifically later. That's actually one of the 3 points by itself. But the first point is just this principle. Evaluate what you're doing, where the pain is going, try and get it to the right place, tighten the feedback loop. This is going to sound like I'm contradicting what I just said, right? Reduce your reliance on customer reporting. After I just told you to make sure it was really good and tight. This is your backup chute, or rather, this is your backup parachute. You don't want to use it. It shouldn't be your primary, right? But you better damn well make sure it functions if you need to pull it. This is what you want to be doing primarily. You want to reduce your reliance on that mechanism when it's there, when you need it, because sometimes you will fail. Sometimes your customers will find out before you do that there is a problem with your product. When that happens, you need that to work. But we don't want that to happen at all. Ideally, it shouldn't. You should always know before your customers do when there's something wrong with your system. So we need to reduce our reliance on customer reporting. There are a couple of reasons that are maybe not obvious for this. One of them, at a previous company that I worked at, we actually ran the numbers. We ran the numbers and found that less than 1% of our customers who ran into any given issue would report it. Less than 1% of our customers would report issues. It sucks. They won't even tell you half the time. But we do this, right? This isn't a logical leap for us. Something breaks, what do? You kick it, you turn it off and on again. You reload the page. You try whatever you can to get around it because it's a pain in the ass to have to sit down and call someone or write a ticket or start a chat. So customers are unreliable. They're also unreliable as a reporting source because you have to vet the information. They tell you they've had a problem, but have they really had a problem? Was it user error? Was it some kind of new and cool form of user error? Was it developer-assisted user error? Was there some pattern in there that just seems like it should have worked one way but didn't? These are all questions we have to ask, and it's not hard data. It's not hard data. We want hard data. there are a few things I want to talk about when it comes to reducing our reliance on customer reporting. All right, the first kind of hard principle in this is to homogenize logging product. Now, I wanted to change this slide because logging product makes it sound like less than it is, because what this should really read, and maybe it would go along better with the ginormous title of this talk, is homogenize the product of your coding instrumentation. What comes out of your instrumentation should be homogeneous, especially as we move into places where we're kind of dropping our monoliths and picking up huge numbers of microservices. This gets really, really frustrating and difficult to try and decipher what's coming out of all of these different places if they all look different. We know we need to instrument our code. So more than just logging, this is logging, telemetry, analytics, tracing data, all of the intelligence that we can gather from our code. Not only do we want it instrumented, but it should be homogeneous. And I'm going to show you some reasons why and how that helps us, things we've been able to do with that at Workiva. I'll jump to it. This is kind of two sides of a disconnected system here. On the right side are the consumers, the things that we want to be consuming our data, our structured data that we're sending through. We want dashboards. We can question their efficacy, but somebody wants dashboards, monitors, alerts, and whatever else. Grandma's whatever else. So whatever else you decide to do with it, and I can show you some things we've done with ours. At Workiva right now, our code base is, we have 4 major languages. So Python, Go, Java, and Dart. You can take a moment to Google Dart if you need to. That's our front-end language. And we have a lot of microservices, more and more every day. We have a monolith in there as well. But all of this data comes through in disparate ways. If you use the standard logger in Python, what you get out is going to look different than your structured data from what might be considered the standard or flavor of the day logging SDK or library in Go. So what we did was we actually got a team together, and as a project, we got a specification, a single specification that everybody in the company could get behind. And we said, this is the structure that our log data will have, our logging, telemetry, analytics. We created different structures and specifications for each of these. We said, this is what they will look like from everything. From that, we then created an SDK for every single language that we use. In this case, thank God, it was only 4. We have a few others, but we have a process for getting an exception in there. But for the most part, we have these 4. This was very helpful to us. This might be very difficult if you have a lot of languages and tons of services that are already existing. This might be difficult to do, but based on what we've seen, I'm going to say it's worth it. Our SDKs interface with every single one of our languages so that our developers don't have to know about the specification. They don't. They can ignore it, basically. They can invoke whatever logging SDK or logging library or analytics, telemetry that they would normally use. We've interfaced with, basically the main one for each of these. And then they can just emit log messages, emit telemetry. Tracing data is bundled in because developers don't really have to do much with that once we've incorporated it into our SDKs. But the data that comes out then is uniform. The data in its uniform state then we shove through a pipe. We use Kinesis. Kinesis then, all of our consumers can pull from the same streams, any stream they care about, and we can read that data. We can have any number of consumers. It's really one of the beauties for us of this. So what do we do with it? You say, that was a giant pain in the ass to get that implemented in my company. What do you do with it? Why is that cool? The second part of this is product accountability. And so what you can do with it is something like this. This is complicated. I apologize. There's a lot here. And if you can't see it all, that's okay. I'm going to try and describe it. It would have been cool to do a live demo, but live demo's not a good idea. So what this is we call it Insight, and this is a dashboard, sort of. This shows us, ranked by their occurrence, the errors in our system. This is one product. Specifically, it's our App Engine product. But this tells us each of these can be expanded. So this section up here is an expanded section. This shows us one specific error. So we have the endpoint up there. We have the count, and its change over a 2-week period. And we can have severity attached to it. We can have the actual type, the Python exception type. Each of these can be expanded to show that. So, and then the other data that we show, of course, is the actual stack trace, the message, and we can attach this to our JIRA tickets. We have teams assigned. We can track this. We even show the last, down there at the bottom, the last comment associated with that. So we can see if you're reading this and you know anything about Python, or even not, it's a token expiration, right? So this is just misclassified. This is just tokens expire. That happens. Why are we calling this an error? So even this last one here, hey, here's the ticket. I spoke to this guy, and we'll just suppress these or get these classified differently, right? This is the Barnacle scraper. It's not sexy, but it works. This is how we track these down. So we have errors. They show up here. Certainly the higher they show up, the more often they show up, the higher up they'll be on the list, the higher priority they are. But there's accountability. We hold our teams accountable for their errors in production. This is another view of that where we also show the errors over time. So we have a graph there. We can see when we first saw the error and its occurrence. That pattern very closely matches weekends. So where it dips, it's a weekend. Usage goes down in the system. So, holding teams accountable. We also have a support card, is what we call it. This is the really crappy thing about speaking like on the second day is everyone's stolen your thunder. So we've had talks on gamifying accountability. This is one of the way that we've done it. So we have our teams here with any given reporting period over 2 weeks. We can show the teams, the number of errors. We have a rolling average, and we can expand those to take a look at the different tickets that teams are working on. Again, this is just holding our teams accountable. This is how we make sure that things don't get kicked under the rug, that barnacles don't get attached. And by the way, that talk on gamifying and the scorecard and stuff gave us some really cool ideas for how we'll play with this in the future. If you missed that, it was a really good one. All right. The third thing in this section on reducing your reliance on customer reporting is maintaining your alerts. I almost hesitated to bring this in because we haven't done as much on this as we'd like to. This is more principle. So I want to talk about a couple of principles here. Our implementation of this was derailed when, sadly, tragically, one of our team members who was in charge of this died around Christmas time. So we're still trying to figure out how things are going to shake out and how we're going to put this on our roadmap. But alerting fatigue is a big deal. If you've ever been in a room where alerts go, where pages get sent out, and there's just too many, you just tune them out. You ignore them. And that's terrible because they're useless then. So we need to stop alert fatigue. The two big things here, and this isn't new, this has been mentioned in another talk, but the big things here are alerts need to represent action. They have to be actionable. You have to do something when you get an alert. If your alert is just kind of look at it and go, this is probably fine, that's a bad alert. You have to have something specific to do when you get an alert. Otherwise, you'll start ignoring it. An ignored alert is not an effective alert. We also want alerts to go to the right place. This sort of rolls in with actionable, but if the action for me is to go tell someone else, that's a bad alert. This seems really, really basic, but it happens. We make these alerts all the time. In fact, if you make alerts and they just go to an alerts room, a general chat room, instead of going to either a specific individual or a specific team's room, that's what you're doing. You're saying you need to be looking in this room and then go tell someone else, go scream at another person when you see the alert. It's bad. But these things take maintenance. This is a maintenance item. Alerts accrete, just like barnacles. Alerts accrete, and they can become obsolete. They require constant maintenance. Not sexy, necessary. So what we had planned was, and what I believe we're still planning on doing, but again, as I said, it's kind of up in the air, which is why I hesitated to bring this up, is to basically just have a rotating team. People rotate in, rotate out, they spend time, and we have regular meetings to go over our alerts. You have to take an inventory of your alerts. You have to go through and say, is this alert effective? According to all of the criteria that we have laid out, is this alert effective? If not, let's kill it, let's redo it, let's maybe add more logic in before we alert, however that needs to be. That's how we need to address alerts, and we need to maintain them constantly. So maintain your alerts. The 3 things: homogenize your instrumented code product, hold teams accountable, and maintain your alerts. I want to talk for a moment about accidents. So this was number 4 on our list. Number 4, accidents. We've heard it said today that every outage is caused by human error. I think at its root, that's true. We've had some really great examples recently. The S3 outage was one that, if you read the wonderfully crafted RCA, I'm sure it took a team of lawyers and engineers together to make that, but it comes down to, again, human error. Somebody in terminal making a mistake. How many people, I'm going to assume everybody, but by raise of hands, how many people work in terminal in production systems? Yeah, okay, like everybody, right? And if I were to ask who's ever fat-fingered a command, who's ever made a mistake, it would be everyone too, or you're lying. Terminal is not your friend. I have a story that I'm sure many of you have similar ones to. I won't tell the whole thing because it's long and boring, but the upshot of it is I made a mistake and I deleted a bunch of data. Now, it was his first support case. We had a new API that we were working with that was created by our devs that gave us access to the back-end data that we'd kind of never had before. And we actually had a support issue that came up where our effective workaround was to use this API. So I jumped in the Python interpreter, was using the request library to hit the API. I screwed up a command, and instead of deleting one piece of information, I deleted everything for an account. That sucks. We were able to recover, and I don't even know if the customer knew, but you guys know that feeling, right? That oh shit feeling. You put in the command, and then you're like, this isn't what's going on. This isn't doing what I expected, and just that pit of your stomach. Oh man, something's wrong, right? That's terrible, and we've all done it. That says something. Terminal is not your friend. What's funny is that we build systems. As an engineer, we look at systems and we try to avoid single points of failure. We try to avoid all of these places where one actor, where one failure can cause cascading failure, can really mess up our system. The thing is, we're that point of failure. You are the least reliable part of your systems. But we don't engineer around that. And we should. And we did. And I'm going to show you how. Consistently, when triaging issues, we have to reach in and do stuff. We're given the keys to the kingdom. It's scary. We don't like it because we can do things where we make mistakes. But ultimately, we need to run arbitrary code to one degree or another in a production environment, or we need to run arbitrary code in some sort of area to affect a production environment. In this case, I'm going to talk about the example for us with App Engine, where we had arbitrary code that we need to run in a production environment. We have a bug, something comes in, it screws up customer data, we need to go in, we need to fix customer data in some way. No panics, you guys are all our customers, but you would know if we really screwed up. So, not all of you are our customers, sorry, that's really pretentious. A lot of you are, 70% of you are. So, what we had to do was get arbitrary code run in a production environment, back on track. But what we want to do is add safeguards. We want to add checks. Again, we don't want to be the single point of failure. So what we want to do first What we did first is we checked this arbitrary code into source control. We want to expose everything we're going to do, everything that we would run via terminal. We want the ability to +1 it. We want the ability to have someone else look at it, to not be the single point of failure, to have at least one other human look over this and say, yes, it's sane, +1, let's do this. So the first thing is we set up a repo in GitHub where all of these scripts would live. And we have certain repo organizational conventions, all kind of stuff around that. But the principle here is get it into source control, get it reviewed. We then have a separate system, which is a compliance control system. So our release management team had already built this for us. We got to leverage it, but it would be something that we could build. It is basically just something that consumes webhooks from GitHub. We consume webhooks. We know what's going on with a given pull request. Rosie can make decisions around compliance control that says, has this been reviewed? Has it been reviewed by the right people? Has every commit been reviewed? All these kinds of things. It's boring, but it's important, right? Rosie can talk back to our developers via the pull request. She just sends updates, makes comments, so we can iterate. If something's not right, our developers know it. They can check in more commits. Once we get to a place where we are fairly confident that everything looks good, we do a dry run. Now the dry run, in this case, our production environment, we've set up a little oasis where arbitrary code can be run without consequence. So everything is done in a read-only mode. This means that we can ensure that our code runs without any kind of runtime errors, that our code is finding the intended data, so what we're looking for is actually there, that any transforms we perform on that data are performed as we expect them to, and we can send output back. So we can even, if we get an issue with the dry run, that goes back to Rosie. Rosie can put that on the PR, and our developers can iterate again. Once Rosie's happy, she knows that she has the required reviews, and we've passed our dry run, the script can then be checked in. So the script gets checked into our production environment where it sits basically in a library. Our developers can then go to that checked in code and say, run it. So this has all gone through a process where our arbitrary code has now gone through a process where we have ensured not only is it reviewed and it's probably safe to run, we then have it in a place where we just say, cool, run it, go. This is our system. Is it slower? Maybe. Not in all cases, not in most cases. You'd be surprised how often our developers have to iterate on these scripts. And if we were doing this in terminal, how many mistakes that would represent. Not all of them massive, not all of them terrible, but we can't afford that, right? This is what we're trying to stop. It's why you wear your seatbelt in the car. How many times do you drive? You guys are in the city, so maybe not often. For me, it's every day, right? How many times have you gotten in a car? Tons. How many of you have been in an accident? Yeah, maybe everybody, maybe. But how many? Not every time. The likelihood of actually getting in an accident is stupid low, but we still put our seatbelts on. Maybe you only do it because it's law. I do it because when the consequences are high enough, you take the safeguards. You take the safeguards if the consequences could be deadly. And they can be. We do this in a couple of ways with some of our other systems too. Specifically, we've started using AWS for our microservices. We've built out a system that leverages AWS infrastructure. So these principles, these things you do, don't have to be just with operational code in your environments. These same principles can be applied to other areas. We do this with our infrastructure code. So we use CloudFormation scripts to bring up resources on AWS. CloudFormation scripts that get checked into source control, that get +1. And then we've actually done a little kind of cool thing on the back end, which is when our CloudFormation scripts run, AWS has this thing, resource signals. If you've used it, cool. If you haven't, what a resource signal is it's a way for you to tell the rollout, the update, keep going or don't. Keep going or roll back. So we've created a binary that sits at our base image level that when we spin up a new member of our cluster says, am I healthy? Is everything healthy here? Do I have all the resources that I expect to have? Can I access everything that I expect to access? Are all of the containers that I expect to be running at the beginning running and healthy? All that stuff. And then we wait for that, and that signals before we continue. So we can screw up our CloudFormation script pretty bad. And when it goes through, it'll roll back if it's not healthy. It's not to say it's bulletproof. I'm sure there are ways we could break it. But it's finding ways in whatever system you have to build in checks and balances so that you are not the single point of failure. How you implement that may change, right? This is our example for one of our systems. But it's the principles around basically verification, treating your terminal commands as code and having sanity checks in place. So the three things, again, if we're going to recap, we want to tighten our customer feedback loop. We don't want this to be the primary way in which we find out that things are broken, but damn, it better work. We want to reduce our reliance on customer feedback. We want the best intelligence we can get from our product. And we want to stop using terminal in production as much as we can. Reduce your reliance on that. If you can eliminate it completely, you get a gold star. Tell me about it, because I want to know how you've done it. It's something that we're working on, and frankly, this is where most of the scary things come from, right? Those are the three things. If you do that, then hopefully you'll have the same results we've had, which is a drastic reduction in the amount of crises. It's been awesome. It's not to say we don't have crises. We still have crises. Everyone has crises. But at least in some parts of our system, we've seen drastic reductions in the number and the severity, and we've increased the involvement of our developers in those high severity issues. I told you previously that we took a link out of the chain. We took us out of the chain. We were the ones that had the access to the terminal environments. Our developers were the ones who had the knowledge. So what happened was in that escalation chain, we would often be brought in just to do whatever they told us to do. Now we're not part of that. Our developers are the ones who are writing the scripts, checking them in, and executing the code. We've taken ourselves out of that loop, we've tightened it, and the pain now goes to our developers. Our developers are involved in all of the sevs they cause. And what's amazing is before, and this is predictable, but where before we would have tickets generated from high sev issues sitting in backlog for weeks or months, our developers get involved, they feel the pain, they make the tickets, they resolve them. Engineers actually want to fix bugs, believe it or not. It's weird. Engineers want to fix bugs, but you have to convince them it's actually a bug, and they have to feel some of the pain. So that's what we've done, and it's been very helpful as we've scaled. Hopefully, some of those principles can help you too. So with that, thank you. Again, my name is Matthew Simons. If you want to follow me on social media, don't. I think I've tweeted once, and it was just to bitch out Wells Fargo for not having two-factor. So I'm not. I think the most active social profile I have is LinkedIn. So yeah, there's some LinkedIn yays. So questions? Yeah, what questions do you have?
Hi. Hi, Saul from Bloomberg. So you mentioned the DAISY system that you had where you were dry running arbitrary code before running it for real. How much of that dry run is technically or truly possible? Like, for example, if you were to bounce a service, right? So how much of the PS, grab, kill can you really dry run, and how much of that is actually supported natively by your system versus things that you had to craft every time?
Yeah, great question. So the question is, if you weren't able to hear it, how much can you actually dry run, right? Like there are systems where maybe that's not possible, bouncing a service, things like that. Absolutely. It's all going to depend on we all have widely varying execution environments, production environments, and that specific model may not work for you. Where we were running arbitrary code in an established production environment, we were able to basically set our database in a read-only mode for those executions. If you are doing infrastructure, for example, doing a dry run might entail doing it on a staging cluster first. A lot of that, again, just comes down to your exact implementation.
Thank you.
Yeah. Anyone else? Okay. Thanks, guys.